Determine the end behavior of the given function f of x is equal to 3x squared plus x minus 2. All right, so what do they mean by end behavior, right? What they basically mean is that what happens to the function's value, meaning what happens to the y value. Remember, you can think of f of x as simply the y value. As your x terms in the function, as they approach negative infinity from the left and positive infinity to the right. That's what they want us to figure out. Now, in order to do this, I created a nice little table, so take a look. Bam. So the first thing is to determine whether the degree of our polynomial is going to be even or odd. Now, I have some other videos on that, so check out the channel in the playlist here. If you, a quick guide here is going to be, when you have your polynomial, when you have all the terms, you can clearly see that there are 3 terms. You just have to find the largest power of x. And that's simply 2. And then you have to determine whether 2 is even or odd, right? So 2 is definitely an even value. In other words, your universe of answers are basically going to be here. Then what we're going to do, oh my God, my brain is fried. Then what we're going to do is, that's what happens when you do, video after video and then students and then students and then videos. Your brain gets a little fried, and then some more students, and then you sleep, and then your kids wake you up at night. And then you don't get any sleep. And then you wake up the next day and drink a gallon of coffee. That's what you have to look forward to. Now, I'm just kidding. I'm so lucky. I'm so blessed. So 3, okay? 3. Is this number positive or negative? That's the second question now. I'm getting very distracted. Is 3 a positive leading coefficient or negative? Well, it's definitely positive, right? It doesn't have a negative sign there, so it's positive. So what that means now is that you have an even degree polynomial and the leading coefficient is positive. This should be the general behavior of your graph. It won't match it perfectly. In other words, the shape might be a little different. It might be up here, it might be a little down there. This might be a little flatter, okay? But what I will guarantee you is this. As x goes to negative infinity, the y will be getting larger and larger and larger. In other words, it will be going to positive infinity. Okay. As x then approaches positive infinity, I also guarantee you that the y value will be approaching positive infinity. Okay. In other words, to answer this question, you can write something like this, that as x approaches negative infinity, your function's value should be approaching positive infinity. And as x is approaching then positive infinity, your function's value, the y value that is, right, will be also approaching positive infinity. That's what they mean by end behavior, okay? Now you can memorize this if you want. You can also gain a little, understanding if you start thinking about what numbers to plug in here, okay? Just start plugging in numbers for x, right? And seeing what's happening to the general, terms of the graph, right? I mean, just think about this. As you keep plugging in larger, this term is going to dominate the polynomial. Okay, because as you continually plug larger and larger values in for x, this term starts taking over the entire value of this function, right? If you were to put in, let's say, 1,000 here, okay? 1,000 squared is going to be 1,000,000. 1,000,000 times 3 is going to be 3,000,000. So 3 with 6 zeros, okay? Plus then, this is 1,000. Minus 2. Do you see how this answer is so close to still 3 million? Obviously, it's not 3 million, but it's really, really, really close to 3 million. As the x continually gets larger and larger and larger, this term will dominate the overall value of the function. Okay? That means that's why I'm only focusing on the leading term. And now you can think about it, right? If I plug in a positive value for x, well, it's squared, so it's always going to be positive. And right, so this is just going to become larger and larger positive. Yes, that's what we said. If x were positive, the function value is going to become larger and larger positive. If I plug in a larger negative value for x, wait a minute, it's squared. So when you square a negative value, it's positive, and this whole thing's positive. Oh my God, by golly, it's still positive, right? This is still going to be positive. So as x approaches negative infinity, the y value is approaching positive infinity. That's all it is. That's all it is, right? And if you still don't trust me, take out your calculator, because for some reason we trust the calculator a lot. So go to 3, type in 3x then squared, okay, plus x minus 2. And what do you get? Hit graph. Look, it matches this general shape over here. Yes? That's the idea. You can also hit second graph, meaning bring up your table. And you can see, look, as the x values get larger and larger and larger, what's happening to the y values? They're also getting larger and larger and larger and positive, yeah? That's what we said over here, look. Right? That's what we said right over here, ladies and gentlemen. And then go backwards, right? As x gets more and more negative, let's see, right? Here's x negative. Oh, wait a minute. Y is still positive, right? See it? See the numbers? That's what we said over here. See? Many ways to look at it. You can use your calculator. You cannot use your calculator. You can memorize this. You can understand if you plug in the values, what term's going to dominate, right? There you go. I think I'm done for today. Take care.